Thank you all for coming today. My name is David Rolnick, and I am co-founder and chair of Climate Change AI. We're very happy to be welcoming you here today to our event on AI for climate action, from data to impact, co-hosted together with Google DeepMind. Okay, our slides are working. Fantastic. AI for climate action. We're going to be hearing a lot of different ways that AI can contribute to the fight against climate change today. I'm really excited to hear from all of our different speakers touching on many different facets of that. I wanted to start out here by giving just a really high-level picture of why this space matters and how many different pieces it contains. Here you can see some of the many different ways that AI can help in the fight against climate change, from climate modeling and prediction to buildings and cities, agriculture, forestry, and other land use. I'm sure you've all read this slide now, internalized all those different things. I'm going to move on. But let's look at some overarching themes here. In Climate Change AI, we've worked to catalyze impactful work at the intersection of AI and climate change, and to really map out opportunities, pitfalls, and other aspects of this space in the process. And we see AI being used in many different areas and many different kinds of AI. I think AI is one of those buzzwords that often gets thrown around, meaning many different things. But here we're seeing many diverse kinds of data and algorithms being used: computer vision, time series analysis, natural language processing, reinforcement learning, machine learning with graphs, and physics-informed machine learning, among many other classes of AI here. And we see many overarching themes for how AI can be relevant in the fight against climate change, from distilling raw data into actionable information that can be used in guiding policies and other kinds of interventions. For example, in remote sensing for monitoring, reporting, and verification, in carbon stock estimation, for example, and in disaster response, mapping out communities that are suffering from flooding in real time, for example. We're seeing AI being used in improving operational efficiency and optimizing the heating and cooling systems being used in buildings or in industrial processes to make them use less energy. We're seeing AI being used in forecasting, in predicting from time series data, minute-to-minute estimates of the supply or demand of electricity to better integrate renewables into the electrical grid, improve robustness to disruption. And we're seeing AI being used in speeding up time-intensive simulations, for example, in models of the Earth system, being integrated into those physics-based models. And we're also seeing AI being used to speed up scientific discovery itself, for example, in helping accelerate the process of materials discovery for catalysts, batteries, and photovoltaics, among other areas. All of these use different AI tools, and some of those are out-of-the-box AI that was developed decades ago. Some of those are the latest AI that's coming out just now. So it's a really exciting time to be thinking about this intersection. Four lenses that I want us to think about today as we go through all of these different talks are responsibility, equitability, impact, and soundness. Thinking about responsibility, responsible AI as a lens through which to consider all these applications. And in the climate context, thinking, for example, about how AI is being used also in ways that are making climate change worse, in facilitating fossil fuel exploration and extraction, in increasing consumption, for example, through digital advertising systems, and some kinds of AI that are particularly large and have a large computational footprint themselves. Equitability, thinking about who is defining the problems that we're working on and who is empowered to work on AI-based technologies, which often require particular kinds of capacity and computational cost. Impact, making sure that we're working on problems that are actually on the ground impactful in climate action, not just sounding cool. And soundness, making sure that the approaches that we're using are well fit to the particular scientific, engineering, or societal challenges that we face on the ground. And we're really well matching algorithms to challenges. Now, in the final moment that I have here, I want to quickly walk you through what the rest of the afternoon will look like. We're first going to have a wonderful keynote by Google DeepMind, then highlight some spotlight projects by innovation grantees of Climate Change AI, a keynote by Climate Change AI, a panel discussion bringing together some of these different perspectives, and then we will have networking time, which is actually going to be on the 21st floor. We'll help guide you up the elevators to that space. space where we can all discuss more freely. Thank you very much all for coming, and I think it will be a really exciting afternoon with all of us. Thank you very much. But I'm not quite done yet. I have the pleasure of introducing our first keynote speaker. So thank you very much for joining us. Anna Koivuniemi leads the Google DeepMind Impact Accelerator, which is an organization that accelerates the social impact of Google DeepMind's technologies and expertise to benefit humanity. Anna was before that a partner in McKinsey & Company, where she worked for almost 17 years, leading the largest AI alliance and the global growth strategy practice. So thank you very much for joining us, and looking forward to your talk.
Thank you, David, for the kind introduction and also covering the AI part so I can cover other parts. The audience here today is very diverse. Welcome all, because we need actually all of you to make sure that we collaborate to get right data and to get right actions to work for climate. So I'm going to talk more about the data. And David, if you would give me the zipper that I can change the slides, it would be much more helpful. Thank you so much. Thank you.
Have 3 times.
And I'm trying to read my notes to make sure that I don't forget anything. But I start with actually a story. We were in amazing Anchorage in front of the beautiful island when the storm came. And we were in the boat with my husband and 4 teenagers. And my husband needed to cut the ropes, get us fast out there before we were on the island. And while I was listening this wind and the waves that were 4 to 6 meters high and trying to keep the 4 teenagers calm, I was thinking about that weather forecasts are actually amazing things when they work. And that realization is also important for sailing. Sailing is a sport of action. You need to have the data in order to make the information, the forecast, not only on weather, but also the route, because there are rocks and everything, in order to turn it to knowledge. Where are we going to sail? How do we put the sails today? Where are we going to end? And some of the masters even translate that to wisdom. Luckily, my husband was one, and he knew how to sail out of the storm, and we ended up safely, because I'm here today. But the wisdom of taking the right actions. So data, information, knowledge, and wisdom. Now, we're not here to talk about sailing, although I would be happy to talk about that as well. But we are here to talk about the big challenge and responsibility this generation has. Is how do we meet the climate change? We all know, hopefully by now, that it's not a simple question. There's very complex different topics we need to address in order to make it correct. And we need to have a lot of wisdom to take the right commitments. Where are we going to invest? What kind of regulations is needed? And we need collaboration, thus this room, to make it happen. But there is no silver bullet in a climate action. There's no one technology that saves it all. So it's actually quite a complex topic. And there's a lot of different kind of data we would need to make the decision, to get the information, and have the wisdom to act correctly. Now, with the right data and with the right problem, AI can help. I'm not always saying that AI is a solution for everything. That would be waste of resources. But there are certain problems that are difficult for human to understand because there could be so much data, or so complex, or so urgent for us to act, that it's important that we actually think about, could AI help to accelerate the solution? Could it help the researchers to find something that is not found else to speed up the actions we take? Or make better actions and commitments? Let's look at some of the data. So we actually went back and looked. We are a scientific organization, so we look, what are the climate scientists doing? And we looked back 5 years and looked into the areas of biodiversity, climate science, energy system, forestry, and land. And seek out how many researchers have been looking into this space. Is this relevant to get the data out there? And we found out that there have been 300,000 papers in the last 5 years on this topic, which is great. We have 500,000 researchers researching a topic where we need to, as a generation, do urgent actions. Great news. And we also looked at is AI relevant, and we found 8% of those scientists last year actually used AI. Now, I'm not saying that's good or bad, because like I said, AI is not solution for everything. It's also not a silver bullet. But it made me think, are they topics, are they relevant researchers where actually we could accelerate either the speed of research, the outcomes, or creativity of the outcomes by AI? And that starts basically with the data. Now, David referred briefly my team. We are part of Google DeepMine. And Google DeepMine's mission is build AI responsibly to benefit humanity. And that's what my team is working. My team is working with our fantastic researchers, which are world-class researchers, not necessarily all of them in climate change, but in AI. And we're trying to see where our technologies, by the way, we have also some amazing climate scientists, but how those models and expertise could actually benefit humanity in areas, including climate change. And when we have looked on where to put our technologies in practice, we often face the issue that there is no data, or that data is not machine learning usable because it's not annotated, or the problem doesn't have actually a set of evaluations which could help us develop a model and train it to the problem. So when we came to that realization, we partnered with our good friends from CCAI to say, who were also looking at the similar topics, can we do something? Can we actually enhance all the climate scientists or all the AI scientists who want to work in climate by enabling them better data? And that started this effort where we are today to hopefully expand the community of creating data gaps on climate action. So what we want to do is to understand what data would be beneficial to solve the problems we're trying to solve. And what is the issue today in the data? And it's basically almost like trying to find the needle in the haystack. It's difficult problem, and we were discussing with David, could AI help us with this one? But we came to the conclusion that humans, people, practitioners who are working in this space are important to find the right data gaps. So that's why I'm happy that you are here in the room and on the video to think about everybody of you can make a difference in here. What does it mean, a data gap? I got a question. So let me give you a few examples. When you have a hurricane or wind or wildfire, there are a lot of harms for the humanity and nature, but often also on property. If we would know which of the houses are damaged, we might not be able to fast realize how many people need shelter, or where we need to actually find people who might be under that, all the crumble that came down. Now, that's a problem where there is a data today, but the publicly available data has been very difficult to address. It has taken a lot of time to translate those satellite images to the real actionable data. And that was a gap, one gap David and his team actually recognized, and I would say Priya also and her team, I don't know where Priya is now, recognized that there's actually not good quality satellite data to do this analysis. Now, I have a good news, actually, because Friday, Google launched a data set with the buildings, which is accelerating this six-folded, and in 24 hours, you can get better data. So this is already progressing. But this is an example where identifying what's a gap can cause an action and help us to make better predictions, help us to make the usable information that we can use to save lives and help people and help, actually, the communities we are in. Another example is basically a solar power. Huge capacity build-outs everywhere in the world, which is fantastic. But actually, we don't have a really short-term, like 30-minute, or even short-term 6-hour data on what are the panel output, what are the clouds that would actually get over a panel and therefore reduce the output of the panel. Now, you could argue why it's important. If we would know exactly what every single panel would produce, we would actually could count on that energy instead of trying it to produce it with other ways. So if we could have those data on the solar panels, we can make better predictions, better optimal power flows, matching demand and supply. Another example of a data that is not publicly available today. So we are here today. I hope it's not a wake-up call for me. Somebody's phone is filling there. We are here to actually today to discuss or start the discussion which data we should collect. Where do we get it? What is relevant to increase our knowledge and drive the actions that are critical to access to climate change? And how do we actually get that data? And how do we share it in a way that it's equitable and accessible to every single climate change scientist in the world? And also the people who have amazing AI skills and could help the AI scientist. So what you see today is a beta version, and I hope together we can make much more better. And the idea would be that we would, with this data, drive research, drive initiatives that we can actually accelerate our actions on climate action. Now, when I was preparing this speech and talking to the team, and I was reading a book about human intelligence, I was suddenly coming with the realization that I have heard this story before, the data and the science and climate. And I'm sure many of you recognize this gentleman, Charles Darwin, one of the greatest scientists of the world. What made Darwin different from others, that he collected enormous amount of observation and detailed them down. And with those observations, he actually saw the patterns and came up with the theory of evolution, or the wisdom of evolution, that actually advanced a lot the science then. So having data is not a new idea. Actually, I was told that he also did a lot of this collection when he was in a sailing boat. And I cannot agree more of his conviction that yes, if we would find the solution for the seasickness, I would have had much more calm time also with the teenagers on the boat. But what was interesting is that the captain of the sailing boat was Robert Fitzroy. And maybe inspired by Darwin, he started to collect the data. He started to collect the weather data. And he was the one who in 1861 published the first ever public weather forecast. And it was not based on what season and what was the feeling, but it was based on his observations. So isn't it remarkable that we had two people in the one boat who were using data to advance science? Now we have today 150 people in this room, and I think there was almost 1,000 people wanted to do. What can we do? Like Darwin and like Fitzroy, I believe that science is observational art, and it starts with the good data. And if we would have the gaps of which we have today of the data collected, imagine what we could do in the science of climate and to advance it, to advance our knowledge about the climate, to advance our knowledge about the potential solution, how to address that. So I hope this event and today is the start of building a community who can make a difference on collecting the right data to be used and to be enabled the AI scientists to use to find a solution fast. Thank you.
Am I back on mic? Fantastic. Thank you so much for that wonderful talk, Anna. We're now going to hear from a few of the Climate Change AI innovation grantees, really rapid-fire talks. These are people who represent teams that were funded as part of the Climate Change AI Innovation Grants Program, for which we are very grateful to the support of Schmidt Futures, Quadrilateral Climate Foundation, Google DeepMind, and Global Methane Hub for their support of these grants. And we're going to hear first from Dr. John Duncan, who's a research fellow at the University of Western Australia, Dr. Scott Laurie, who is executive director of the citizen science platform iNaturalist, and then Dr. Junlu Kuyu, who is assistant professor of electrical and computer engineering at the University of Washington. These are going to be very rapid-fire talks, but we will have a panel discussion with these projects featured afterwards, so there will be a bit more chance for discussion and questions surrounding that, and you'll have a chance to talk with them afterwards in the networking time. So thank you very much for bearing with our tight schedule here, and it's my pleasure to welcome John to the stage to start us out. Thank you very much, John.
Okay, hi everyone. So 5 minutes, I'm just going to dive straight in. Our project's focus was mapping flooding and croplands in Fiji. It was a collaboration between the University of Western Australia, Fiji's Ministry of Agriculture, and the University of Sydney. So just a very quick bit of background context and geography. Fiji's croplands are concentrated in lowland and coastal areas. They're the orange shades on the map that you can see, and they're incredibly flood prone. Every year, Fiji gets tropical storms, tropical cyclones, intense rain events, and that causes flooding on all of these croplands. It's especially damaging to the agricultural sector. Annually, this runs to millions of dollars of agricultural losses, and you have the situation where a lot of the households whose income is close to or just below the poverty line include agriculture in their livelihood mix. So these frequent flood events are just a brake on their economic development and advancing their well-being. After the flood events in Fiji, officials in the Ministry of Agriculture go out into the field and have to do damage assessments, and that's to verify where flooding is occurring and to facilitate relief and recovery payments to farmers. But the challenge with that damage assessment exercise is it's time-consuming and laborious. There's a relatively large area to cover when flooding is extensive. You've got a limited number of agricultural officials you can put towards that task. Many of the farms, and these are often the small-scale and subsistence farms, are remote and inaccessible, so hard to cover in that damage assessment exercise. And you're doing all of this in a post-emergency, post-disaster context. So there's two pieces of information that could help with that damage assessment exercise. One is knowing the current extent of cultivation, and the other is an estimate of where flooding is occurring on the landscape. And that's what we've been focusing on in our project, is using machine learning to convert information that's contained in stacks of satellite images into an accurate and current map of cropland extent and an estimate of where floods are occurring. So I'm just going to dive into the cropland mapping component for a second. And cropland mapping in Fiji is a good example of where global land cover maps don't have equal accuracy across the Earth's surface. If you look at the agricultural class in a global land cover map over Fiji, you'll see that it doesn't correspond to where cultivation and farms are actually on the land surface. And this figure up here illustrates the consequence of that. In blue, I've mapped out the flood extent following Tropical Cyclone Yasa, which hit Fiji in 2020. And then in orange, I've mapped out the cropland extent from 4 different land cover products. And you can see, depending upon the land cover product that we use, we're going to get a very different estimate of the area of cropland that was flooded. So to address this challenge in our project, we've built a machine learning system that generates an annual update of land cover for Fiji. It does this for the entire nation, including all the outlying and smaller islands. It provides a much more accurate representation of where cultivation is occurring. It also includes a range of other land cover classes that are relevant to the work that the Ministry of Agriculture are doing. We've produced these maps annually now back to 2019, and we've automated the process for their production moving forward. All of these maps are openly available on the Pacific Data Hub, and that's the main open data sharing platform for Pacific users. You can also access these maps as web map layers, and there's a web app that you can go to zoom in on a location of interest, select the year that you care about, and view the land cover, and then download that data as an image for your work. And that's primarily the portal that our partners in the Ministry of Agriculture are using to access this data on a day-to-day basis. Behind these land cover maps are a couple of other data sets we've put together through our project. One is a large-scale training data set covering Fiji that consists of thousands of locations across the Fijian Islands that we've assigned a land cover label to. And then we've done extensive quality checking and lots of field verification to ensure that features we're labeling in an image correspond to what we see on the ground, and those labels correspond to the land use definitions that the Ministry of Agriculture work with. We've also built a nationally representative test data set, and we can use that to do accuracy assessments of our maps, but also allows other users in Fiji to do inter-comparisons of different land cover maps over Fiji to identify which map would be most suitable for their use case or application. So I think I've just whizzed through everything and really scratched the surface of what we've been doing in our project, but I'm very happy to talk more about it with you and answer any questions later.
And thank you so much for that lightning talk, walking us through so much really fast. Next, we're going to hear from Scott. It's all yours.
It's so great to be here. I want to thank David and Climate Change AI for hosting this and also for these grants. So our grant was on mitigating climate change on biodiversity using AI. So and I want to acknowledge my co-authors on this. So I'm Scott Laurie, a naturalist, but I'm Oisin McCode from the University of Edinburgh, and also Tom Brooks from IUCN. I mean, as everybody here knows, we're in a climate crisis and also a biodiversity crisis. Biodiversity is critical to this because biodiversity is what's giving us the resilience to adapt to climate change for our food systems, our ecosystems. So it's critical that, that we make sure that our biodiversity system can survive this climate onslaught. Okay, so I wanted to quickly talk about our, just a quick outline. So I want to talk about the vision for our project, the progress so far, and the impact that our project's having. So I run iNaturalist, which is currently the largest citizen science site in the world. So we have millions of nature explorers outside who are generating observations of plants and animals globally. We've gotten about 200 million observations. And as Anna was saying, a huge part of this is, can we generate the data that we need to manage biodiversity in the coming century? This is about 1 hour on iNaturalist. In the next hour, we'll get about 10,000 new observations and also annotations from people around the world who are vetting the quality of this data. And a great test case to see if the data that we're generating is good for addressing problems like we were just talking about, is trying to make predictions with it and seeing if those predictions are good. So one of the key predictions that we need as scientists to stop species from going extinct is an understanding of distributions. Many of you are familiar with the IUCN Red List, which is what Tom Brooks, our colleague on this project, works on. So IUCN mandate is to assess species and get trends over time about every species in the world. Are they threatened? Are they not threatened? How are those threats changing over time? And distribution is a key part of this. So for example, for this spiny-headed tree frog, you can see the distribution map. Small range species tend to be threatened, so distribution is a critical piece of this. So the question is, can we make good distribution estimates from this unstructured data that iNaturalist is generating? So in a nutshell, the challenge of this project was to take this unstructured observation data, which is scattered, let's say just that 1 degree observation grid cell over that kingfisher, and can we replicate something like these hand-drawn IUCN range maps, which are drawn by experts? And that's what led us on this whole geomodel exercise. So the geomodel is there on the right, and this is an attempt to use iNaturalist data in an AI model to make predictions of range maps that are similar to what IUCN is doing manually. So I wanted to quickly talk about progress so far on this project. What we're doing now is in one large AI model that's simultaneously analyzing hundreds of millions of points from iNaturalist with climate variables as well and land use variables. We can make joint predictions of about 100,000 species, which is really exciting. So this is, for example, the American pika, which is a species that's very threatened by climate change. This is a species that lives on the top of little mountains, and as the climate's warming, it's going up and popping off the tops of those mountains. One of the key statistics that we're trying to do is get these models to perform as well as IUCN. So the blue is like our prediction. The pink is that hand-drawn, expert-drawn range map, and we're starting to analyze these and evaluate these. Right now, we're getting a F1 statistic of about 0.65, and iNaturalist is all an open source platform. What's been fantastic is to get the AI community to come help us with this problem, and we're holding challenges and things to get people to sort of come up with new approaches to model this data set to answer this problem. One of the things I'm really proud of this, as Anna was talking about, filling data gaps, is the iNaturalist community that's generating this data is we're updating this model every month. So every month we deploy a new one that has about 2,000 to 3,000 more species as we're generating more data with iNaturalist. And the community is really invested in this. So you can see we're going to hit 100,000 species by the end of the year. And what's great is the community says, oh, this is fantastic. I've been working on these species of this part of the world trying to improve the model. And I think having that virtuous cycle between the data generators and the model predictions, the AI community is really, really critical to getting these gaps filled. So in terms of project impact, everything's open data. Getting this data out there, getting the model predictions out there is key. We're really excited this stuff started getting to IUCN. But I wanted to quickly talk about some of the impact through the iNaturalist platform, because iNaturalist, we have tens of thousands of small-scale conservation projects around the world where people are actually on the ground trying to improve the habitats for nature. And what we're trying to do is deploy these predictions into tools that are useful for this kind of core activity of setting conservation priorities. So here's an example of a small park in Costa Rica where there's a small range species. This is, almost all of the species range is in these parks on the Osa Peninsula. So I just wanted to quickly talk about, this is a park in California where we can quickly use this tool to say, these are the small range species. These are the species that should be conservation priorities for you in this park, and help landowners manage them. We also can get people to start improving. So one key thing is, what species should you have that you don't have? So these are migratory salamanders. There's huge communities on iNaturalist that are now able to say, okay, what can we do to attract these small range species like iNaturalist? And last slide, I also wanted to say a huge, huge role of this is early detection of invasive species. So now we can use these distribution maps and real-time observations that are coming into iNaturalist to say, hey, here's a species that is appearing that's invasive. Let's get rid of it before it takes hold. I saw my first spotted lanternfly walking here on the sidewalk, which is a great example of these invasive species. That's probably here to stay. But if we can get this real-time alert system where as soon as these species show up, they get eradicated, and this model is helping us do that. Thank you so much.
That's just super inspiring, Scott. Thank you so much. And now we're going to hear from June as the last of our... Sorry. It's really exciting. We're going to have a chance to talk more with all of the speakers later. Thank you so much, June. All yours.
Thank you. Pleasure to be here to tell you a little bit about why African countries will need stronger and smarter grids to adapt to climate change impacts. So Ethiopia and Kenya are two countries in East Africa which recently had their worst drought in the last 40 years. And on top of that, we see vulnerable populations, especially women like in northern Darfur, who are experiencing or bearing the brunt of extreme heat. And so our argument is that Africa will actually need abundant and reliable electricity to adapt to climate change. And in fact, the International Energy Agency estimates that if Africa is to actually meet their climate goals, as well as expand electricity access, they'll need about 8-fold times the energy demand and energy supply. And for this to happen, then electricity grids will play a very key role. And so detecting grid issues, thinking about weak grids is something we are grappling with. For example, we see that a lot of grids in sub-Saharan Africa are experiencing about 5 times as many outages, as well as 20 times the duration. And if we think about system losses, they're about 4-fold when we compare them to North American utilities. And even beyond that, when we think about just the financial sustainability of electric utilities, it's really poor. Only around 4 utilities are actually making profit and meeting above 100% of their operating and debt service costs. And so why is this important? If we are to detect these grid issues, we need comprehensive measurement at grid level, coverage by smart meters, phaser measurement units, which are really expensive. That's what's being done in other countries. But then already we can see that African utilities lack those resources and capacity to consistently measure grid performance. We see only about 20% of utilities do report outages, and that's not frequent. And if we look just overall at the dearth of data in sub-Saharan Africa, it's really huge compared to other countries where there's open source data for accountability. We're not seeing that on the continent. And so we call for near-term and low-cost innovative approaches to bridge these data gaps by thinking about low-cost sensors, thinking about how we leverage satellite data, thinking about how we leverage AI and open source models, as well as how we create some collaborative data platforms for this. And so our project partners online did see this gap, and they have been deploying low-cost sensors in different parts of Africa, more specifically in Ghana, where they have over 1,000 low-cost sensors to sense voltage at the distribution level. This has been happening for over 5 years, and so far have recorded over 50,000 outages. And so in this project, we're thinking about, okay, well, we have the data. So how do we then move from data to impact, right? And so for this project, we are leveraging some ML models to think about estimating the grid topology. And this would enable us to figure out where are the losses and where are those fractures in the grid. And this would enable us to then think about targeted investments in grid resilience. And we're thinking about pushing this forward and thinking about layering social equity. So how do we do that in a socially equitable way? And so paired with this project, we're also thinking about then how can we also bring in partners. So recently we did launch the data set in Accra, brought together local utility stakeholders to think about how can this data be used within the utility. It's well enough for us researchers in other countries to do this work, but how do we build capacity on the ground? And so beyond this data, I think something that has been important is for us to think about then how can we actually move the needle between that data, research, and impact. And one thing has become very clear is how do we bring in transdisciplinary partnerships. It's very clear that we cannot just have one set of stakeholders if we want to move from having that data to impact. And more so bringing utilities and government stakeholders from the start, thinking about how do we co-create and ensure that the data is relevant and contextually relevant for everybody. So that also means incorporating community engagement and thinking about how that data reflects on the ground realities, which is different in different contexts, as we've seen as working with these data sets. As well as something that has been really important for us is how do we strengthen that local capacity within local utilities on the continent, as well as local academic institutions, and creating accessible decision support tools. And that's why releasing our models and data was really important for us. Lastly, I'll just have this here, and you can be able to access the GridWatch dataset. And Genevieve will be here in the panel to talk more about this. Thank you.
Thank you so much, June. We heard 3 really exciting and inspiring projects, which are just some of the examples of the many different kinds of work that are being done around the world in many different sectors to facilitate AI and climate action. And I'm really excited for all the other grantee projects, which unfortunately we couldn't showcase here. So thank you very much. Thank you very much to these speakers for sharing their work. We've heard those examples. We heard a really inspiring call for why this kind of understanding both what is on the ground needed in terms of impact in AI for climate, and specifically why certain kinds of gaps exist and what we can do to fill them from Anna. And now we're going to hear a keynote from Priya Donti, who is my co-founder and fellow chair at Climate Change AI, and also an assistant professor in electrical engineering and computer science at MIT. Priya is, by the way, an AI 2050 scholar, fellow Zeeble scholar, DOE graduate fellow, and one of the MIT Tech Review's 35 Innovators Under 35, among many other awards. And she's going to be talking to us about the different ways that we at Climate Change AI and in general have worked to understand gaps across the space, really quantify those, and what we've been doing about that. So thank you very much, Priya, for speaking.
All right. Thanks so much, everybody. It's great to see such just an amazing group of people kind of in the room here, right, at this event. And I really hope that for those in the room, this is a kind of continuation point, or for some of you, a starting point in really strengthening collaborations among each other in order to actually help move this space forward. And so this is what I want to talk about today, right? What does it actually mean to scale the space of AI for climate action in a responsible, impactful, equitable, and sound manner? And I contend that there are 2 big pillars to this. The first is democratization. AI for climate is not just a small number of entities with existing tools and expertise, kind of developing solutions in a small space and then releasing them to the rest of the world. Right? AI for climate action is something that needs to be owned by a diverse and global set of stakeholders who are able to not just participate in implementing or using this work, but actually shaping the space as a whole. And this requires ensuring that more people are equipped with the literacy, skills, expertise to actually understand what it means to do responsible AI in the context of climate action, to allow solutions to come from ground up, and also to enable that the tools and processes, for example, organizational processes, are in place to be able to actually actualize those ideas. The second big pillar here is coordination. So climate change is inherently, right, a global, multidisciplinary, multi-sectoral problem, and we need to make sure that people are able to work together effectively to actually make progress on solutions. So how do we actually enable people to coordinate better, to actually find each other, and to find the resources that they need to do work in this space? At Climate Change AI, we're trying to make a dent in these two pillars of democratization and coordination. We have 4 action areas in our work. The first is expertise and thought leadership, education and capacity building, community and collaboration, as well as research to deployment infrastructure. So diving into these things. When we think about the space of AI for climate action and what needs to be done, that's actually a big question. What needs to be done? What work is actually possible to do? How do we fill gaps in things like data? How do we ensure that we have the right policies in place, that we're directing funding the most effectively as we can to actually enable, again, responsible and impactful progress everywhere in the world? And so some of the work we do at Climate Change AI is to actually try to shed light on some of these questions. For instance, you saw kind of right at the beginning our taxonomy of different ways AI can be used for climate action. And we've also done some work on trying to enable discourse on how policymakers and funders can best direct their resources to both enable the use of AI for climate action where it makes sense, as well as actually align business as usual AI with actual climate goals. Another big pillar of the work is growing the talent pool. So how do we make sure that more people, again, have the literacy, skills, and expertise in order to, implement projects in this area or shape programs, shape organizations that might leverage AI in this context? And so our work has focused on a combination of in-person, in-depth, and kind of high-touch training with various kind of existing and future leaders in the space to help enable them to actually kind of catalyze further work in this area. So our in-person summer school, for example, has trained about 60 participants from across 6 continents. And we also aim to provide scalable virtual education, trying to give kind of an overview of, again, where is it that AI can be used for climate action across different sectors, and what does it mean to do this work in a responsible and impactful way. We've had kind of something like 16,000, I think is the number on this slide, people participate in these programs, and I think it really shows, again, this kind of need to make sure that people from many different contexts are able to kind of upskill and take advantage of this kind of work. A third aspect is actually facilitating better coordination, so knowledge sharing and connection building. So we have, for example, a workshop series that we run at the major machine learning conferences, as well as online platforms to facilitate connection building among different people. And then, as you just heard, right, we give grants to teams that are kind of collaborations between academic institutions and deployment partners across, for example, government and industry, who are working to actually both leverage AI for impactful climate problem, but also actually create data sets that can go on to further catalyze work in the area by allowing other people to work with that data. And while you saw a few of the innovation grantees talk just now, the projects kind of represented here span things like better discovery of CO2 sorbents, neighborhood-level energy optimization, improving shrimp aquaculture, and improving kind of our ability to measure forest carbon stock. And so I mentioned those 4 projects specifically because those grantees are in the room, and I hope you'll kind of find them and engage with them at various points. So having given that overview of, again, kind of a set of things that we are aiming to do in order to address these 4 pillars in service of democratization and coordination, I want to dive into one specific project, and in particular, we've heard a lot about data today. And this kind of asked this question several times of how do we improve the data landscape in order to enable impactful AI for climate work? So kind of in service of that question and in service of the fact that no one person or entity is going to be able to solve the data problem, but in fact, actually addressing the data problem is going to require large-scale collaboration and coordination among a ton of people. What we decided to do is say, can we actually survey people? Can we actually talk to people who are working on AI and climate change-related problems and actually get a sense of where data is the challenge that is holding them back? And can we surface that to the broader community as a call to action to then actually go fill those data gaps? And so in service of that, kind of telling you more about this, I want to share 3 stories of particular machine learning for climate use cases where data was a bottleneck. The first is AI for ecosystem health assessment. So as we've heard, right, climate change is having huge implications for kind of our species diversity and the extinction of species on the planet. And measuring indicators of the health of different ecosystems like species richness and species dynamics is actually very key in shaping efforts to conserve biodiversity and preserve ecosystem services. One kind of cool tool that we have at our disposal here is sound. So the idea that you can actually have devices that are recording sounds that are heard in nature. Think about when you're walking through a forest and hear different bird calls. And we can actually analyze these at scale using technologies such as AI in order to allow us to actually understand what is going on with respect to biodiversity, for example, in remote areas that are hard to survey manually or in under-resourced areas where on-the-ground person capacity is difficult to come by. And there are a lot of really cool organizations that are collecting bioacoustic recordings today, citizen science organizations, academic organizations, NGOs. And there are a couple of issues, though, in actually leveraging this data. One is the issue of personally identifiable information. I don't want to walk through a forest and have my conversation with my buddy on my hike recorded, right? So that's one issue. But an issue I want to talk about today is actually size of the data. So if you think about recordings-related data, this data is huge. If you record 1 minute of sound data, depending on the resolution, you're talking 300 megabytes to a gigabyte of data. And to contextualize what that means, if you record one location for 2 years, you're looking at the equivalent of storing 200,000 high-definition movies. One location for 2 years, right? So we're really talking about a huge amount of data here. And the challenge is that those organizations who are actually collecting this data then have difficulties finding ways to actually store it in a long-term way. And when people try to download it and your server is experiencing heavy download requests, the server crashes. So there's something we can actually do about that, right? We actually have a lot of levers to try to create more accessible and affordable resources for data storage and transfer. And this can actually help unlock the potential of data that in some ways already exists, but is not actually being effectively utilized because of these data storage and data access related challenges. So this is one example of what we mean by a data gap. Another example I want to dive into is climate and weather downscaling. So because it's very computationally intensive to run a climate model or a weather model, this means that a lot of the forecasts that we have of climate and weather are actually too coarse for a lot of things we want to use them for. So for example, weather models are often giving us information like, for the entirety of New York, I'm going to give you one data point on what kind of precipitation and temperature look like. And climate models are saying for the entire state of New York, I'm going to give you one data point on what that looks like. And when you're using a weather and climate forecast to do things like figure out how much power my wind turbine is going to produce, or figure out what I need to do on the ground to enable disaster response, that's much more fine-grained than city or state level, right? And so we need to actually have techniques to figure out how do we actually get more fine-grained information about what the weather and climate will look like. AI has actually started to be very powerful for this because what we can basically do is take climate and weather forecasts that are projected backwards, take the weather and climate data that we have backwards, learn the relationship between those, and now when we have a climate forecast in the future, we can apply that same relationship to figure out what do we think the climate and weather is going to be in a fine-grained way in the future. This relies, though, on actually having high-quality, high-resolution data on the weather that is actually pulled, and this is often pulled together from many different sources, like weather balloons and satellites. And unfortunately, while the ingredients of having this data are often out there, many of these data sets contain biases because they're often generated partially through simulation, for example. They are not readily accessible. They might not be public. And this is particularly acute, for example, in the Global South, where the data is extremely scarce. For example, the kind of density of weather radar stations in Africa is 20 times less than in the US and Europe. And this is even within Africa unevenly distributed. So this is a huge problem. So what do? One, collect more data. That would be great. And governments and international organizations can really help by making sure we're expanding weather observation networks in places where that is necessary, and also promoting better sharing of the data we have. And researchers can actually also help by creating better methods to combine the ingredients of data that we already have. So these are called assimilation methods. And this can help us to better structure and take the data we already have and make sure it's leveraged. A third example I'll give here of another data gap is in AI for power grid management. So as we start to use large amounts of time-varying renewables on power grids, this challenge that we face on power grids of maintaining an exact balance between electricity supply and demand is getting harder and harder. And so we actually need new approaches to make sure that we can actually manage and keep up a grid that has large amounts of time-varying renewables. How this works, since you can't take, I work on AI for power systems, I can't take my fanciest technique and put it on a real power grid. That would be, what if the power grid breaks? And so we need simulation environments that actually take detailed power grid data and allow us to test out different techniques on these power grids. The challenge, though, is that a lot of the data we actually need for this is often private or anonymized. And this means that the simulation environments that we're using are actually overly simple. Think about trying to model the entire human body by having 3 organs. Doesn't work, right? And so we really need more granular data about power grids in order to enable these simulation environments. And what we can do is that power grid operators and researchers can really collaborate to try to figure out how do we improve power grid simulators while still maintaining data privacy. And this means, for example, taking existing data that's real, but actually, for example, creating synthetic versions of it that still reflect some of the realities of the power grid, but are still not breaking privacy. There are many techniques like this that actually can be adopted, and that enables us to actually develop next-generation power grid management techniques. So these are 3 examples of kind of AI for climate use cases where there's something we can actually do about the data landscape associated with that in order to unlock progress. And those are 3 examples. But in our work, we actually looked at many more ways in which these particular use cases could be serviced by better data, as well as many other use cases across different sectors and disciplines. And in particular, we assess AI for climate data gaps across different sectors, categorized by, does the data set even exist at all? So do we need to collect it? And if it does, are there ways that its obtainability, usability, reliability, sufficiency, so forth can be improved in order to actually do this? And this is currently released online as a kind of tool that's currently in beta where you can look through different data gaps that we've kind of collected. And this is a seed, right? What this means is basically we've started understanding, where are certain data gaps that are bottlenecking actual people on the ground. And the call to action is that we need you, right? So 1, if you're working in AI for climate and you have a particular kind of data gap that you'd like to surface that would actually enable your work, we hope you'll actually contribute it to this tool. And if you're a funder or a data provider or somebody else who works to kind of fill data gaps, we hope you'll use this sort of, again, this reflection of the community's needs as guidance to potentially direct efforts to fill the data gaps, as well as let us know if maybe you have filled a data gap that is already there where you'd like for that information to be serviced to the community. And so zooming back out, that was a dive into data. But again, the goal here is really coming back to this question, right? What does it mean to scale the space of AI for climate action in a responsible, impactful, equitable, and sound manner? That's going to require the efforts of people, in and beyond this room to actually make sure that we're moving forward on democratizing the space of AI for climate action and enabling people to work more effectively together. And again, we hope that you'll use this as an opportunity to form collaborations with each other and, of course, work with us. So thanks so much, and I'm excited to turn it over to the panel.
Thank you so much, Priya. We have a panel discussion bringing together some of the different threads that we've seen throughout the day. So I will hand it off now to the panel moderator, Dr. Uyi Stewart. We're very glad to have you joining us today. Dr. Stewart is Chief Data and Technology Officer at data.org, was formerly Executive Director of Data Science and Technical Operations for CGen Inc., which is now Pfizer, Director of Global Development Strategy, Data and Analytics at the Bill and Melinda Gates Foundation, and co-founder and inaugural Chief Scientist at IBM Research Africa in Nairobi. I will hand it over to you. The panel is all yours. Thank you so much.
Thank you. It's been really inspiring just listening to all of the presentations so far. Nowcasting, forecasting, early warning detection systems. These are fantastic tools that are out there that AI can enable. But there is a big problem, and I think Anna put it really succinctly, which is that to get these things to work, we need to fill the data gaps. Data is the engine to make this happen. But how can we collaborate to fill the gaps? And how can we achieve on-the-ground impact? Those are questions that I can't answer, but I have a stellar panel here. And I have some great questions. And so I'd like to invite to join me on stage, John Duncan, please, Scott Laurie, Genevieve Flashhopper, and Peter Battaglia, and of course, Priya.
Okay. Sorry, it was just.
I don't know where.
Still on.
Sit in the middle.
Don't forget to turn the mic on.
Yeah, it's one. All right, we're going to just jump right into it. There's a lot to cover here. It's how can and how to. And I'm going to ask you, I'm not going to do a long intro. I'm going to ask each of you for each question, just introduce yourself quickly. But I'd like to start with Scott. Yeah. So you lead iNaturalist, a thriving online social network of people sharing biodiversity information to help each other learn about nature. Are there any lessons learned that may translate to enhancing community and coordination in the AI and data space?
Yeah, I mean, I think that what is exciting about AI is that it's so data hungry. As we've seen with this, and so much of the progress is really computing power and just getting the right kind of data. And I think what's really exciting about iNaturalist is just if we can incentivize and engage people to get outside and be that data collector, we're able to unlock data at a just completely different scale. In particular space I work in, biodiversity, that was all done by museums, painstakingly collecting. There's just not enough scientists out there to do that. It's amazing that we can unlock that, but exactly the problems that you were saying, data gaps. We know iNaturalist works better in the Northern Hemisphere, places like Europe and North America. I'm really excited to find ways to engage people in places like the global South, where we have the most biodiversity, and we also have the hardest time getting that kind of engagement.
Excellent. Thank you. And I'll come back to you for the follow-up, but I just need to get through. Priya, it's been data. And so we've talked a lot about data today, and rightly so, honestly. But I want to ask you a very specific question. What, in your opinion, are other big barriers to deploying AI in climate-relevant applications more widely, and how can they be overcome?
Yeah, so I touched upon this a little bit in my talk right now, right? But I think the people problem is a really big one, right? Making sure that we have the ability to make sure that more people from around the world are actually able to, have the tools to not just kind of come up with good ideas, right? People are the experts in their own problems. If there's anybody who's going to have expertise on, where is AI potentially helpful to solve my own problem, it's the problem holder. So how do we kind of empower more problem holders to actually, for example, have knowledge and skills with respect to AI in order to be able to kind of come up with those ground up? Hi. And then I think then this means, right, also then how do we kind of provide, right, tools, things like compute, things like the ability to discover other people, things like data, in order to allow people to do that. And so I think it's really this idea of kind of broadening participation in who is able to shape the space and who is able to contribute is the only way this is going to work, because no one entity or set of entities top down is going to solve the climate problem, like using AI or not, and so we need to empower people to be able to do this ground up. And this is something that I know you actually have thought a lot about, and so if it's okay, I'm curious for your thoughts on this as well.
Absolutely, and you gave a very brilliant summary earlier, right? I work for an organization that is focused on empowering communities in the Global South to do the kind of things you talked about. And so one of the things that we really need to start thinking about is that we need to generate data at a spatial scale that is sufficient to inform decisions in those communities. Right now, it doesn't exist. And I want to go back to Anna again, that those gaps are hugely there. It's possible to do it, but we need to build capacity. And that's a big gap right now. Thank you for bringing me in, but I'm moderator now. Actually, you do underscore one important point about infrastructure, and that's a good segue to Peter. Pete, we heard about the work of Google DeepMind, which addresses problems that are relevant to many different fields, weather prediction, power systems, material science, etc. The question for you is, how do you ensure that your work is actually necessary and well-grounded in the needs of the context you're serving, rather than AI being a hammer seeking a nail?
Thanks. So I'll just introduce myself too. So I'm Peter Battaglia. I'm a research director at Google DeepMind, and I oversee our sustainability program, and I also lead our weather effort. So this is a great question, and I really think it kind of gets at the heart of a lot of the things that I'm thinking about and trying to kind of enable in our teams and elsewhere. So if you take a step back, what modern machine learning really is taking some problem in an application area and translating it into this sort of standardized generic formulation that then you can go take your sort of toolbox of machine learning tools and start applying them to. And ML and AI researchers tend not to be experts in a domain or an application area, and so that sort of poses this problem. So how do they, otherwise, if without guidance, they are going to just be trying to build their hammers and then just swinging them in the dark, and it's not that helpful. So I think that what we need to understand is that before we start saying how do we select problems, we need to make sure we're speaking the same language. And what I mean by that is we need to have the AI and ML researchers actually know enough about the application areas and the domains to be able to communicate with those folks who know the problem much better. On the flip side, the folks in the application areas and the domains need to understand, they need to have some fluency in machine learning and AI so that they can help communicate their problem and bring it over into the realm of the AI researchers. And so I guess what I would say is, it's not just about building bridges, it's actually about seeing your role as close, if you're a researcher, seeing your role as closer to an application, and if you're in an application, seeing your role as more, it's more important that you have data science and ML in your background. And I think then the answer to the question is, if you're an AI researcher, go out into the domain and ask the question and respect the person who's giving you that answer and try to understand it. On the flip side, if you're in an application, try to understand how ML people approach these problems, and then sort of frame your problem in that language.
It's fantastic. I mean, the need to have interdisciplinarity is crucial. Yeah, and that brings me, because I want to now go to low middle income countries and context and settings. I'm going to ask you a question, Genevieve. Your work with Nline has aimed to address the power grid data problem in low middle income countries head on by building and deploying low-cost power grid sensors. And now with RISA Research, you're working directly with meteorological departments in East Africa to improve climate and weather data availability. I have two questions for you. What have been some lessons learned in the process of collecting, open sourcing, and leveraging this data that may be useful for others who are trying to fill the data gaps in low middle income countries, as Anna has put on the table and Priya emphasized? Second, besides the lack of data, what are some other challenges to ML deployments in these settings that you have observed or that may perpetuate inequities in the space?
Thank you. Those are great questions. So my name is Genevieve Flaspohler. I'm the executive director of RISA Research, which is a small technology nonprofit that works to develop technology that serves people and the planet. And my background is as a machine learning researcher and a technologist. I did my PhD in machine learning, but the kind of whole span of my career has been trying to find ways to connect back to application domains that I really care about and to serve people and the planet. And so as I answer this question, this kind of question of data gap, I think the word gap is really important to focus on here, because if you're trying to address a gap, you're trying to kind of connect from A to B, where the gap is not the point of that connection, it's going from A to B. And so I think one big lesson that I've learned in trying to address data gaps is to come to the problem with a lot of humility, that the data gap is one piece, to force yourself to think very, very clearly about the pipeline that you're trying to fill the gap in. If you're going from A to B, have you thought about the steps from A to your side of the road and where you hand off to on the other side of the road? And for example, there's a very different sentiment in saying, I think that there are all of these data gaps in weather station and meteorological data collection in sub-Saharan Africa. I want to make weather forecasts better, so I need to fill that gap. Versus saying, I've understood all of the actors that go into making a forecast in Kenya that a farmer might use to make an agricultural decision, and I know what that person needs, and I'm ready to fill that gap. And so I think forcing yourself and myself to think with specificity, with clarity, to bring in these coalitions of the willing. I got to work with great partners like June, folks all over the world on the projects that I work on, and that's kind of the most critical, important thing to making sure that the gap that you're filling really matters. And I think there's all these exciting kind of talk of leapfrog technologies and ways that AI is going to enable photovoltaic rollouts to solve the energy access problem in low and middle income countries, or that machine learning is going to enable weather forecasts to be really good and available and localized all over the world. And I think something to realize is that those are super hard engineering problems. Getting distributed renewable resources integrated into a grid and providing reliable electricity to people who really need it is an engineering problem that's been solved nowhere in the world. And to ask low and middle income countries who have not put us in the position that we're in, have kind of marginal energy usage compared to a lot of high income countries around the world, to solve that engineering problem with very few resources is deeply unjust in my perspective. So I think acknowledging that if you have the privilege to work on AI for climate problems and you have the opportunity to collaborate with people who have less resources and less privilege to work on those problems, that you should kind of reach out, connect the line from A to B, and think about kind of your role as a technologist with humility is my overarching lesson, potentially from the work I've done.
That's great. Thank you, Genevieve. One of the innovation projects was on Fiji. And John, I want to ask you a direct question. So in your project, you're working in partnership with the government of Fiji. How do you ensure that your project is sustainable in the long run? For example, ensuring that the government has the capacities to use the solutions developed.
Thanks, E. So I think we do a few things related to that when we set up and run our projects. I think capacity building is a really important part of that, but it's important to stress that that's whole team capacity building, and a big part of that is, say, the developers and those with technical skills really getting to understand the context in where your data or your model will be deployed, and the sort of organizational and the institutional nuances that you need to be aware of to make sure that the data set you're producing is impactful and useful. I think a big part of that relates to what Genevieve was just saying, really understanding the context, the pipeline of where the data you're producing fits in. The way we get at that is to try and do things in a very iterative manner. So very quickly create a prototype of the data set, test it out in its deployment context with the end users. In that, you can sort of spot where there might be sort of skills gaps that you need to address, but you also see what works, what doesn't work, what needs to be refined. And then you rinse and repeat that process over and over again, and you sort of slowly morph your initial idea into something that's suitable for where you're aiming to deploy it. Another thing that, and this might be specific to working with agricultural ministries in the Pacific, but that we found is if you can align your project and the data sets you're producing with a specific activity that the government is undertaking, that's really useful for a couple of reasons. One is it's kind of a nice anchor for your project. So as you start your project and there's lots of interesting new ideas you hadn't thought of that you can explore, you've always got something that's pulling you back to the specific need for that data set. And the other reason is those activities the government's going to have to do every year or in response to certain events. And so you've ensured that the need for the data set you're producing is tied to those and not tied to a particular project deadline and timeline.
Thank you so much. These are fantastic insights. And I do have more questions, but I would love to now engage this audience. And I do have some questions already from sliders. So those online, please. I see your hand. I'm coming to you right now. But those online, I'm encouraging you, please, to just send in your questions. We do have time, and you all have been fantastic keeping to time. I'm going to start with you, Scott, and then I'm just going to alternate between online and questions from the audience here. Yeah. So there's a question to you, Scott. It starts out with congratulations. It says, "Congrats, Scott, on impact with iNaturalist so far. Have you done anything to assess the impact of interventions on specific species and or overall biodiversity?"
Yeah, I mean, I think that's what's so interesting. I mean, with iNaturalist, it starts with just engagement, trying to get people just to pay attention and care about the natural world. The next step is monitoring, and monitoring really is that measurement, baseline. Where are we? How are things? If we can quantify, how biodiversity is doing. And then the next step is trying to get people to actually improve it, and then hopefully be able to see a shift in that measurement. So I feel like we're doing a great job in the engagement. We're doing a great job in terms of the monitoring baseline, but I do think we have to complete that circle so that when people actually do an intervention, they can actually see the needle move. And we can do it. I think that's where AI is going to play a really important role, though, is taking this messy data and making, synthesizing it into understandable metrics that can be, so the shift can be seen.
I like that. We can do it.
Yeah.
I'm going to take two questions from the audience. I see your hand, and then I see you up front. Can you pass the mic, please? I think the lady first, if you don't mind. Yes.
Hello? Okay. Hi, my name's Ali. In my work, I work on industrial decarbonization. And one of the things that's really important is the anonymized data sharing between private entities and assets. Something I run up against a lot is if only there was a public forum where you could receive information about how something was manufactured. I've seen some examples of this in Europe, like Cantina X doing an open data exchange. What are the forums you've seen in your work, either private sector or public sector, for places that would allow like disparate corporate entities to connect in bettering their emissions footprint?
That's a great question, actually. Data sharing is at the heart of whatever we do in coordination. Who's going to take that? Freya?
Yeah, I have a thought. So, as mentioned, my own work is about AI in the electric power sector, and there are often kind of reasons with respect to kind of, personal privacy, kind of, infrastructure security, that data can't be shared necessarily very, very widely. And also, depending on the types of entities, there's actually some distrust in terms of one entity having access to another entity's data, both, for competitive reasons, but also because, no entity wants to be called out by another entity for having done something wrong.
And in those settings, one model that I've seen work well is the kind of idea of a kind of a third-party entity that is a trusted broker that kind of has access to the data. That data is not going to be actually shared out with anybody else or with any of the other entities, but they're trusted to sort of take the data from these different entities to generate insights that are kind of strengthened by the fact that you do have access to multiple entities' data, and to share back out the insights, but not necessarily the data. And this can be one way to, with this idea of sort of a trusted insights broker, I guess, to make sure that you kind of have control over who is seeing your data while still making sure that industries are able to collaborate more effectively to actually have strong insights based on all of the things that they're seeing.
Absolutely. We need to explore this anonymization and privacy-enhancing technologies even more. Yeah? Take one question.
Could I just add a follow-up?
Yeah. Sure.
I just wanted to share another example of this broker that I think Priya mentioned, which is really powerful, is in the meteorological space. The WMO, the World Meteorological Organization, acts as this incredible broker, getting weather station data from nations all over the world, pooling it, and then providing this kind of safe, anonymized, trusted way for that data to be shared and distributed. And when I went from working in the energy sector into the meteorological sector, I was just shocked and amazed at how much incredible open data sharing there was there. And Priya, you work in the energy sector. I mean, it's difficult to get the world's utilities to share data and to get data in the energy sector. So I think, yeah, this idea of a broker and kind of what organization can play that broker is really powerful.
Yeah, I don't want to derail this conversation, but there's a better data sharing happening in the climate space than in the health space for obvious reasons. But we'll pick that up another time. Let's take your question.
Thank you. I'll stand, I guess. Hi, I'm Cheyenne. I'm a college student actually here at Columbia and just came from the UN Summit of the Future, so probably representing some of the more younger folks in the audience today. But I did want to ask a question on the point of collaboration, because that was a point that was underscored very heavily. I think, Peter, you also mentioned kind of reaching across the aisle, doing a little bit more than just kind of, not just sort of building bridges, but also more like taking the time to learn more about what the other end of the table, what their background is, and kind of how to think like them. So my question is, you mentioned like researchers should think a lot like the practitioners and the applied people who are working like in the field. My brain kind of went to like policymakers, because a lot of times you want your policymakers to come up with policies and interventions that are very grounded in the research and then the science that we have. Science diplomacy has been a really big thing talked about at the UN. And also, John, because you're working actively with research, with the government in Fiji, I think my question is like, how do you kind of bring science and AI and ML to a lot of policymakers, be able to convey to them, especially given many policymakers are more non-technical, and also given the age of many policymakers, especially here in the US, it might be a bit difficult to get that across. So what are some challenges in collaboration that you've seen, and how have you tried to mitigate those? Thank you.
Peter?
Thanks. So I admit I haven't actually spent much time trying to convince policymakers to adopt AI solutions for climate. But I think that we are sort of encountering this. Maybe an example is with weather. So there's sort of in the field of machine learning for weather forecasting, there's a lot of very powerful machine learning AI models that are suddenly appearing. And I think there's questions about how not only like weather bureaus, but also like the sort of government funding that and the public that funds these agencies, whether they're going to use these, why should they use these, why should they open up more data to make these machine learning methods better, things like this. So I think that the way we're trying to think about it is, again, figure out the incentives. It's sort of the same thing as I was saying. It's like sort of go and say, why are there public-funded weather bureaus to begin with? Like, why is it in the public's interest? And then work through those examples and say, okay, so these are the top things that need to be done. So how, like, specifically take that very seriously, right? We're not trying to show off some kind of fancy machine learning method. What we're trying to do is sort of take the next step in the technological evolution that traditional numerical weather forecasting has taken us, and then basically offer that to the public and to policymakers and things like this. So I think it's understand exactly why they're already doing what they're doing, and just use that as justification for what you're doing and help solve their problem even better if possible.
That's great. Genevieve, I'm going to ask you a question that's coming online. Today's discussion has been largely academically focused. What do you think is needed, and what are your organizations doing, in this case yours, to catalyze the AI climate startup ecosystem?
Yeah, I think that's a great question that I'll just tie back to this idea of every successful project from an idea to impact being a pipeline, and you really only ever being able to play one small role in that pipeline. So I think there's a huge role for academia to play in terms of exploring, generating ideas, kind of creating genesis. And then there's this role of kind of dogged, feet on the ground, long-term effort to make something happen in a place that I think is very hard to do as an academic. And this is a moment that academics, I think, need to bring in private partners, need to bring in nonprofit partners that can really provide that kind of dogged, long-term partnership. And for me, this is the reason that I kind of left academia and moved to this nonprofit and startup sector, because I felt that there were problems that I wanted to solve, things that I wanted to solve, pieces that I saw that were not being solved in technology for climate change, that were harder to do as an academic and easier to do as a startup or nonprofit actor. And then I think the vice versa, partnering with academics that are able to provide this kind of genesis of ideas has been really powerful. And I think there's probably other folks who have a lot of experience on that idea here.
Well, I'd say from coming at that from an academic's perspective, we've been quite fortunate to be able to work in Fiji for almost a decade, and that gives you the opportunity to build up relationships, build up good connections, have a lot of failures along the way that you learn from, and to get a good understanding of the environment and the institutions that you need to work with to make things successful. But there is that element of projects have a sort of finite time span. And so I think there is a bit of an onus on you as an academic, if you're working in that space, to be aware of that, to always be looking for the next funding opportunity, to, even if there's a lull in projects, to make sure that you're still maintaining your relationships and your connections for those reasons. For stuff to realize an impact, it does take several years really often for that to come to fruition. Yeah, so I'd say it's probably a bit of responsibility on academics. If you're trying to work in that space and you want to make things happen, you really need to take responsibility for that and make sure you find ways of maintaining those long-term connections and relationships with your partners there.
That's a great point. There's more questions online, but I want to come to the room as well. Yes, I see two hands on this side. Yes.
Is it working? Oh, sorry. Hi, my name is Zishan. I just wanted to ask that other than weather data sharing, is there any practical example that you guys can give, especially in the energy or utility side, where people are sharing data or companies are sharing data, and there's a model that has been developed on that, which can be a good example to point on, this is great, people should do this, and this is the way?
Who wants to take that?
Definitely biodiversity with a naturalist again. I mean, I was just yesterday up on a guy up north who I had to visit, who's trying to rewild his farm. So he's saying, I want to take half my farm and make it whole wheat for biodiversity. So his whole thing is, and he's logged over 3,000 species on iNaturalist. And what we're trying to do for us is to use AI to say, can we actually take these measurements he's taking and turn those into indicators so he can see that the farm is actually a better portfolio for biodiversity than it was. So I think that has the same kind of forecasting, prediction aspects that you're talking about in weather for the biodiversity sector.
Excellent. Thank you. Yes. Oh, well.
Hi, everyone. My name is Angela. I lead a global nonprofit that's been supporting to surface people's lived experiences and then use that to advocate for change over the last 16 years. And what I'm curious about is what role can community-generated data sets play in some of the work that you're doing to try and move towards, to address climate change, and with a specific focus on not just collecting data from people, but giving them agency to actually participate in solving the problem. So yeah, it would be good to hear some practical examples around how you're applying that in your work.
And it's a great question. Priya is going to lead with that, but I'm going to tack on one question from online so that we can just... so in response to or in reaction to your presentation, Priya, this questioner says, great list of data gaps. We've noticed some of these in our field as well. Have you any plans for how we can close those gaps, and who would do that?
Awesome, thanks. So I'll try to take both of those. So to the first question, I'm actually going to not share an example from my own work, but actually I want to talk about one of the other innovation grantees that didn't present today but is in the room. And Björn, maybe raise your hand because I'm going to talk about you. Yep, right there. So Björn and team's project Forest Bench, they are trying to kind of, help get better data and information on kind of indicators of forest health as well as carbon stock. And that really requires contending with the fact, and Björn, correct me if I'm going to get any of this wrong, but this really requires contending with the idea that when people are, for example, engaging in deforestation, there are real reasons for that. There are real economic reasons for that. And that data collection, kind of as we try to kind of enhance carbon stock, often happens in a very extractive way where certain entities are collecting data and the communities that are on the ground there are not benefiting from that at all. So I think one of the really cool things about the work in that project is really thinking about, okay, well, if there's sort of an economic incentive to deforest, can we actually provide an economic incentive to be the collectors and providers of that data by actually paying people on the ground to collect that data and ensuring that they have ownership and say in how it's used. And in doing that, you kind of actually, again, allow a community to participate and provide resources for them to do so. And so this is, I think, one piece of work that I thought really did this well and that I was very excited by. In terms of this idea of, we're cataloging a lot of different data gaps, who's going to fill them? I think this is where kind of, targeted engagement comes in. So we really want to try to engage people who, for example, are invested in collecting particular modalities of data or, policy entities who are particularly interested in a particular sector and try to engage them to this matching problem, basically, of, where are there data gaps that we've cataloged that are well suited to a particular entity's interests or capabilities, and really try to get, again, like a broad community of people to actually act on this, because no one entity alone is gonna help do this.
Thank you, Priya. I hear a lot of discussion around capacity, rightly so, discussion around infrastructure, rightly so, but you're bringing up a great point about the governance of the data itself, the ownership of the data, some kind of fundamental principles in terms of the collection and use of the data. I don't know if we're getting there, but these are big questions that we have not addressed as a community. But I want to come to you, Pete. Question online, and I'll come back to the group here. A questioner says, can you tell us more about Google's initiatives in climate and AI and any potential opportunities to get involved?
Yeah, that's a great question. So, one thing I'm proud of is that Google has these very public climate sustainability commitments, like the 1 gigaton 1 gigaton CO2 reduction by 2030, and things like net zero 24/7, so clean energy, hourly matching at the data across all of Google's operations by 2030. So we're sort of fortunate in a way that at Google that we're able to sort of couch some of our climate sustainability work under these very public and very strong commitments that the company's made. I think Google's a very large company. There's lots of parts. I can speak for Google DeepMind. There's also Google Research has a ton of great work in climate sustainability. For us, I think the way to think about it, we only launched the sustainability program in the last year or so, year and a half. We're trying to kind of get some of our stuff that we had, some of the projects we'd collected, and get them delivering their results to kind of have a more public face and start getting feedback. So I think in terms of getting involved, email me. Email me or email the authors of papers that are on our teams that are in the area that you're interested in. and let's just start talking, because we're absolutely very, very equipped also with like Anna and GDI to make contact and sort of form partnerships with different individuals and experts in the community, organizations, nonprofits, governments, private companies, things like this. So I think depending on who you are and what you're sort of interested in connecting with us on, I think we can often do that.
That's great. Just email Pete. Well, you had a question, right?
Yeah, my question is actually the one that you picked up on Slido. Okay, you sort of answered it.
Oh, we got to it. Okay. I think from my right.
Hello. My name is Ajay. I'm a principal at Cli Ventures. We invest in climate and AI. I had a question around insurance solutions. With climate change and the use of data and AI, it seems like that would be one domain where we can have significant impact, yet the opportunities for collaboration are probably the most problematic in that domain. I was wondering if anyone has had success in meaningfully driving that. Thank you.
Who's going to take that? Anyone?
I can say something briefly. I haven't had success in meaningfully driving that, but I do know that one of the kind of big areas of interest for one of the projects that I work on, which is kind of mid to long-term weather forecasting in East Africa, is specifically around providing better insurance mechanisms for agriculture and for farmers who are kind of unable to plant regularly on the cycle of the rainy season because of changing climates. But no more deep thought than that, other than that I think there is interest in thinking down those routes.
Thank you, Genevieve. One more question. Okay, yes. Oh, sorry.
Okay, all right, awesome. Yeah, thank you so much all for the insightful answers. So I think today we got to a lot of, again, research-heavy, kind of really academically interesting, sexy applications of AI. But we didn't talk much about its potential to accelerate human knowledge work and human collaboration, which is what like LLMs tend to shine at. And I wonder if you have anything to share about your work on applications that accelerate that, like accelerating the work of, permitting authorities for clean energy projects, or accelerating the work of corporate sustainability teams, or of policymakers, or like government net zero planners. So all of that stuff.
Yeah, I can jump in on this, kind of wearing two hats, right? Both kind of a researcher and an educator. I will say I think we're in an age, right, where there is a ton of information, and there's definitely a lot of kind of, temptation and sort of desire to kind of, have it processed and summarized by LLMs. I think it's worth realizing that we're in an era where a lot of the people who are users of these tools were not educated in an era of LLMs. So there was kind of a lot of knowledge and skill building that came from having to actually contend with the literature, having to contend with the permitting information, and really get a mental model of what's there, what it means for information to be high quality or not. And then as a result, when you get something like a summary, you actually have the context to understand the many different subtle ways in which that summary might be right or wrong. We are now entering an era, though, right, where we're now saying, okay, we're having a lot of people have LLMs be the first way they interact with the academic literature, the way they interact with permitting processes. And I do worry about the sort of loss and lack of intuition and mental model that comes from interpreting those results. We've already seen analogs, for example, in kind of flying airplanes, where before kind of autopilot was really big, when some extreme situation happened, a pilot knew how to deal with that, not because they'd seen it before, but because they had the intuition to figure out what to do that was outside of the data they had already seen. And we have kind of, some various famous examples now where pilots who were trained entirely kind of using autopilot and didn't have to do very much in normal situations, then completely failed to figure out what to do when something extreme happened. So I realize this is an anti-answer to the question, and I do think, right, there are places where kind of LLMs are and have been helpful here. But I really just, when we think about the mental model of where these technologies come into play, I think we really have to think about who are the humans behind it, what are they actually able to contextualize from those answers, and make sure that we're thinking about both of those things at the same time.
Thank you, Priya. I'm going to take one last question. Yes.
Hi, my name is Giovanni Coppini. I come from Italy, from CMCC, the research foundation. We have launched in the UN decade, Ocean Decade, we have launched a program for the coastal ocean. And we are working on many of these aspects on citizen science and numerical modeling and AI. But one gap or one bottleneck is the accessibility, especially for the global south, to cloud infrastructure. So in your experience, how much the cloud accessibility is a bottleneck or not, maybe?
Genevieve, you want to take that?
Maybe I would let the Google folks speak to the cloud accessibility. I do think, I'll just tell an anecdote I was telling to Nadia earlier, just that I think there are security concerns with a lot of these data, especially grid data, that countries want to keep their grid data on-prem within their own countries and not export it. And I think that it is difficult to participate in kind of the global cloud computing infrastructure without transporting data off-prem. And so I think figuring out ways for countries to use cloud resources while having the ability to keep their own kind of government data and that independent is important. And I
think you covered it.
Thank you. Okay. All right.
I mean, I could also just say there's also do you know the Cloud Public Datasets program? So this is a program that Google Cloud has to just host like all the data, basically, like as much well-organized data that's not going to, I think, require too much like maintenance and sort of overhead. But so I think you can, there's lots of opportunities there. As far as I'm not sure if you're talking more about like compute and sort of getting into these types of things. Yeah, I think that's probably something where we can do better, really.
I could maybe chip in with one comment that's a bit more positive on that front, which from the Earth observation space and sort of working with geospatial data, there's tools like Google Earth Engine that are free for researchers to work with. And like in the last 10 years, they've unlocked incredible like computational capacity for students and researchers in low and middle income countries or anywhere in the world, but especially there. And you're seeing like heaps of really great analyses being done using platforms like that. So there are like, examples where cloud computing does sort of reduce barriers to doing sort of analyses that wouldn't be done previously. So, yeah.
And just really briefly, in situations where also data is very large and therefore hard to kind of transfer between different places, bringing your computing capability close to your data is a way to actually avoid the data transfer problem in the first place and actually allow the compute to happen in the same place. So this is also a model that's been used across a lot of places that's been effective.
In the last 45 minutes or so, we've focused on two questions. How can we collaborate? And how can we work together to achieve on-the-ground impact? And you all have done a fantastic job. We didn't touch on incentives, but it's at the heart of collaboration. And so as I wrap up, I want to ask another question. Why should we collaborate? Why should we collaborate? It's a simple answer from me. We just don't know how hot the world is right now. We're all assuming, but we don't have data that is comprehensive and representative around the world. Just let that sink in, right? That's why we need to collaborate, because we need the whole picture. We need everything, the ground truths. With that, help me to thank my great panelists here.
I'd like to second that big thank you to Dr. Uwe Stewart and all of our wonderful panelists for a fantastic discussion. The discussion is not over. We encourage you to go up to the 21st floor, which we will escort you up to through the elevators. where we have refreshments and ability to engage further on these topics.